want to thank you for joining us. It's great to see everybody here, especially now that we're fully into summer and the weather's getting nicer and there are more reasons to be out and about. Appreciate you joining us and contributing to the community. Speaking of that, feel free to chat in the chat. Let us know where you're from. Let us know what you're working on, interested in, any questions. If you're hiring, if you're looking for a job, jump in the chat. Let us know. This is a great community for making connections. So make sure that you make use of it. And beyond this session, make sure you join us in Slack, because that's where you can keep connected to everybody else in the community, which is much, much larger than any single event. And the conversation is constantly flowing there. So you can join us at the link below. Any of these links will take you to where you need to go. But with that, let's get started. So I want to thank our first sponsor, CloudBees. They've been with us a while. You should know them if you're in the DevOps space. Go check them out if you're interested in building stuff, and if you're interested in one of the major players in the market. Also, big player in the market who's also a more recent sponsor of ours is BMC. Traditionally coming from the data space, they've been investing in DevOps and sort of end-to-end value delivery more and more. And without further ado, last but definitely not least, our favorite sponsor, JFrog. And here from JFrog is Ari and Gowtham, who's going to be speaking today. But first, I'll hand off to Ari to tell us about JFrog and what's the latest.
Cool. Hey, thank you so much. I'm going to go ahead, if you don't mind, Steve. I'll go ahead and share my screen real quick.
Sure.
And so, man, I'll tell you, the people that are here are going to have a really, really cool opportunity, because the odds of winning this is really going to be cool. I'll tell you about that prize in just a moment. But hi, everybody. My name's Ari Waller. I am the Meetup Event Manager for JFrog. I have the privilege of being on the developer relations team here. And we are so glad to be part of the Toronto DevOps sponsorship community. This is, I believe, going on our third year. And it's really awesome. Always appreciate Steve and the consistency, even during the pandemic. And stuff like that, where a lot of DevOps communities took a little bit of a break. I always appreciated that Steve really made sure that the content was there for the community, and really speaks volumes. Sebas as well, and the others behind the scenes just do a great job. For those of you who are not familiar with JFrog, we are the DevOps software company. We were founded in 2008. We're obviously Steve's favorite sponsor. I'm just kidding. Many people in the DevOps community know us and have heard of our flagship product, Artifactory, which is considered by most as the gold standard for managing your artifacts and dependencies. JFrog's always been committed to the DevOps technologies community. We developed a free tier of the JFrog platform for you to enjoy, and it's free to use for your projects or just to play around with as long as you like. No credit cards required. And if you were here back, I believe it was in November, Melissa McKay gave a talk then, but she's actually teaching next week a hands-on workshop called Container Image Management for Everyday DevOps. So I'll drop a link for that if there's any interest in joining a hands-on workshop during the week, if that's something that you would like. I'll drop it in the chat shortly. So I'll share my screen really quick, and let me see if I can find the here it is. See if everyone can hopefully see this. Can everyone see the slide okay? Okay, cool. So we are going to actually be raffling off and giving you a chance to win a 3D printer. So I consider a 3D printer one of those things that it's been out for a little while, but people haven't really dived into 3D printing. And this is a great entry-level model to go into. It's actually rated the best entry-level model out there. And somebody here today in attendance is going to have the opportunity to win. Now, I can't, because of compliance purposes, give out raffles over the internet for lots of reasons. However, a winner is selected within 3 business days and is contacted after the meetup. And once the individual who wins or the selected winner formally accepts the prize, then we will share their name with the entire community. So we're very excited about that. Community happiness, one of our core principles at JFrog, and their virtues, and we're really excited about that. But without any further ado, I know we didn't come to hear me today. I'll drop the links in the chat, and I'll let Gowtham Neerukonda introduce himself. He's one of our solutions engineers over at JFrog, and he's got a great talk today prepared. Thank you, Steve. Thanks.
Thank you, Ari.
Okay, let me share my screen. Okay, so today I'm going to talk about OSS Security and Compliance Monitoring and Gatekeeping. First thing, a quick introduction about myself. My name is Gowtham Neerukonda. I work as a solutions engineer at JFrog. My role here on a day-to-day basis is to talk to customers, understand their challenges with implementing their DevOps, and at the same time, recommend them, suggest them with multiple solutions, and make sure that they get the best out of our solution, which is the JFrog platform that we offer. Of course, you can find more about JFrog and what we offer. I'm going to switch to the topic today in the next slide. Just as a quick background, many organizations that are developing software today are heavily relying on open source software components. And the number is quite surprising, by the way, because 85 to 90% of the software that they compose are based out of these open source libraries, OS dependencies, or frameworks. And only 5 to 10% is actual custom code that they develop where their business logic resides. And at the same time, there's a recent trend, change in the paradigm wherein attackers are shifting their focus towards software supply chain. And you can see the numbers here that there's a wide growth in the spread of these attacks, especially in 2021, where everyone started more focused towards software and moved into the COVID environment. Now, we're going to see what is the main challenge when it comes to consuming these open source dependencies, and what are the shortcomings. And at the same time, today in our presentation, I'm going to discuss about what are the various approaches organizations are taking towards monitoring these OSS components consumption, and at the same time, what are the gatekeeping measures that they are trying to take, and the benefits of each approach as well that I'm going to discuss today. Now, when it comes to OSS components, they are mainly consumed through public registries. These can be NPM Central, Maven Center, JCenter, Go Center, or any other public registry, Docker Hub, from which you download these dependencies. Now, because these open source components are widely available and commonly downloaded and tried out by various corporate organizations, open source contributors, freelance engineers, as well as small startups. And at the same time, these are also available for the attackers to try them out and see if there's any known vulnerability or weakness associated with these open source components. And in a way, the exploit kits that are being developed against these open source components are free and publicly available at various sources as well. So even when it comes to a novice attacker or a hacker, it's quite easy to do some reconnaissance and find out the organizations that are using a specific library version or framework version or web application version, and try out some various exploit kits that are available to compromise this organization. So as a entity that is developing software and implementing DevOps around your software implementation, you are very much bound to these vulnerabilities, like bound to get attacked or bound to have these risks associated with these open source components. And at the same time, today we are going to talk about what are the risks associated with these OSS components. The first one being the security vulnerabilities associated with these OSS components. It can be something like a backdoor that opens up for an attacker, or some sort of a vulnerable class that is being exposing some level of information or data or access to your system. It can be in terms of licensing. Some of the open source components doesn't provide you a way to reuse those components or publicly share them across, or make it part of your paid software entities. For example, this is completely dictated by your legal teams, by the way. The third category can be long-term sustainability. Maybe this is something like an OSS component that is never been maintained, or fewer commits in a given 6 months period to 1 month period. You need to be aware of these shortcomings before you actually designate these open source components to be utilized in your organization for long term. And at the same time, when it comes to software quality, because this is open source and maintained by multiple contributors, there's no specific rule that the quality of these components are being constantly monitored before they are made available in the public registries. There might be some malicious intent, knowingly or unknowingly, that is part of this software that is made available in the public registries. So these are some of the challenges and risks that we are trying to address in this session. I would like to take a pause here and see if you have any questions so far. Okay, so any specific set of audience here in the call that is already aware of these OSS risks or compliance checks that they are being part of, running some tools to evaluate or gather some information around the OSS reliance that your organization is having? I'm just curious to know if you're dealing with this kind of a challenge in your organization as well.
It's not something that was on my radar until recently, but there's been a lot of conversation about the software bill of materials and like government legislation around understanding what's in software, whether it's open source or inner source or coming from anywhere. Just understanding that not everything comes from a single source, and software these days is coming from all over the place and being assembled and reassembled and reconfigured. So when I think about this, I think of that software bill of materials idea, but I'm curious to hear if that's just a fraction of what we're talking about, or if that's something that you think is closely connected to this.
Yeah, definitely. SBOM initiatives are picking up a lot of traction nowadays, especially with the Joe Biden's mandate last year that every organization that is working with a federal government or related entities should maintain and submit the software bill of materials, or SBOM, as a part of working with the federal government. And we are also seeing that this will take a ripple effect on all the other verticals and industries as well. So in my talk, I'm going to talk about how an SBOM can be generated and can be streamlined in your organization as well, and some of the approaches that you can take around it. So to Steve's point, again, in the field, while talking to my customers and DevOps practitioners and developers, I'm seeing that there's a lot of emphasis being laid on maintaining the SBOM as well as maintaining the OSS checks along the DevOps pipeline as a norm in many organizations. Something that has been in the back burner for a long time and picking up a lot of traction after the recent discovery of vulnerabilities in the Log4j library as well as Spring Shell, and the SolarWinds attack is also as an serving as an harbinger to all of these events. Okay, so let's go ahead and see what are the solutions that are available for this problem statement. So the first and foremost solution here, which is our primary focal point for the presentation today, is software composition analysis tool. It basically inspects every package that is part of your organization or that is being produced by your CI/CD tool in order to list out the open source components that are found in it and it will identify the full list of open source components using which a given build or binary or artifact is being composed of. And it utilizes a publicly known trusted vulnerability database that maintains the records of various vulnerabilities, licensing issues, as well as operational risks associated with an open source component in a central vulnerability DB, and maps it with the existing component list that is found in your organization to deliver these results. So that's where a software composition analysis tool is mainly helpful to provide information on what your organization's OSS reliance is around, and what are the violations in terms of security, licensing, and operational risks associated with your application. It will be able to showcase it for you. Is anyone aware of an SCA tool? Raise your hands if you're having some kind of an SCA tool implemented in your current DevOps implementation right now. Okay, Steve, did you get a chance to work on a SCA tool for your initiative?
I have not yet, no.
Okay, so we'll talk about it, and maybe this solution can be helpful in your pursuit. Okay, so coming to some of the basics around the software composition analysis, the first important aspect is the National Vulnerability Database. This is like a central DB that maintains and collects information from various sources about publicly disclosed vulnerabilities in open source software. And the common convention that they use to denote or designate a certain OSS vulnerability is called CVE. This is a MITRE standard. It's called Common Vulnerabilities and Exposures. So not all vulnerabilities and exposures will have a CVE number associated with them, but at some point or the other, as it becomes a commonly acknowledged vulnerability and being accepted into the NVD database, you'll be able to see those details as well. Now, why are we talking mainly about this vulnerability database, and why is it important? Whenever an SCA tool detects certain open source component, it uses this vulnerability intelligence platform to map the OSS component and showcase the list of issues that are found in the given component. So the quality of alerts mainly depends on the quality of the intelligence platform that you're relying on. And keep in mind that not all vulnerability database sources are heavily updated time to time and are staying ahead. Many a times, the NVD gets the information slightly delayed, maybe a few days to few weeks, whereas some of the proprietary private vulnerability DB systems have a dedicated security research teams that work on these various package feeds that are coming onto the public registries and try to stay on top of these issues. And they maintain their own private intelligence feed that your tools can have access to. Again, depending on what sort of SCA tool you have, these are some of the things that you need to be worried about or taking care of in order to make sure that you're getting the right information as well as earlier access to these information points. That's why having a good vulnerability and threat intelligence platform is really important. Any questions so far? Because I'll be introducing a lot of new stuff in the coming slides. So if you have any questions, I would love to answer them as we move through these topics. Okay, I see no questions. Okay. So coming to the various approaches organizations are taking towards OSS monitoring and making sure that they're aware of any software supply chain attacks in the process of consuming these OSS dependencies, one of the first approach is monitoring the dependencies that are being consumed in the dev environment. Keep in mind that from the point wherein the CI tool comes into the picture or the build tool comes into the picture, you have a standard approach wherein there's an enterprise-wide CI solution like Jenkins or some sort of a next generation CI/CD tool that is a common tool across the entire organization. So you have more visibility and control over the dependencies that are being called upon or being consumed by the CI/CD or build tool. Whereas when it comes to the dev environment, it's kind of like an open space. Any developer can consume any dependency from their preferred public registry, and it's like a haystack. There's no common standard agreed upon when it comes to a developer consuming these dependencies. So here we see that the developer in the step number 1, I'm slightly switching to a workflow diagram wherein it talks about how the specific environment consumes the dependencies. Here in this case, there's a developer trying to declare certain dependencies in their local IDE or build tool. And generally, these requested dependencies are resolved directly from the internet and various public registries serving as a source of dependencies for the given packaging technology, like Maven Central for Maven, NPM registry for NPM, Docker Hub for Docker dependencies, etc. So once these dependencies are resolved, they kind of verify and validate that the local build is successful. And after performing some local tests, they commit the changes into the version control system. So in this case, you can also see that these dependencies being consumed, there is a very broad list of public registries that the developer is relying on. And this is a very tough task to monitor these sources and at the same time enforce certain rules on consumption from these public registries directly. So here, the benefits being shifting left in the DevOps lifecycle and making sure that you are getting alerted and notified about these vulnerabilities and licensing and operational risk well ahead. So it's faster and easier to take action. And this is primarily focusing on feedback to the development team. And some of the example tools here can be IDE plugins that can showcase the information on vulnerabilities, CLI tools that can provide quick feedback on the by scanning the source code or the local build that has been generated and printing out a report that the developers can use to empower themselves. Now, as a quick heads up, do you have any developers employing these sort of tools? And as a DevOps practitioner, were you acquainted with these sort of tools to get notified about the open source components in your day-to-day job? I'm just curious to find out if you were able to touch these side of things. Yeah, Steve, go ahead.
Is this something that folks are using something like SonarQube for, or is SonarQube really just looking at what's in the code and not necessarily what the code is connected to?
Yeah, so SonarQube is a popular static analysis tool. It is looking at the custom code to find out if there are any vulnerabilities or issues associated with the custom code that you are writing. Of course, at a broad level, this is what SonarQube is used for. But nowadays, it's like everyone is moving towards a platform approach and taking the SCA analysis as well, or the software composition analysis as well, into their list of capabilities that they do. But SCA is completely different from static code analysis, because here in the SCA, we are talking only about open source components and using a central intelligence platform to find out what are the vulnerabilities associated with it. In case of a static analysis, it's just reading through the code and finding out if there is any known vulnerability associated, or like based on the pattern or based on the way in which you have written the code, if there are any issues with it. Does it make sense, Steve?
Totally makes sense. Thanks.
Okay. So again, as a quick heads up, we have certain IDE plugins as well coming from JFrog side. If you're interested in providing this feedback to your developers, they can install these IDE plugins in Eclipse, IntelliJ, Visual Studio, and VS Code. to get the feedback, and we have a broad spectrum of feedback tools in terms of CLI tools and Git scanning as well. Of course, there are many other vendors providing these solutions as well. If you already have an SCA tool in place, it would be good to know about these feedback tools and share it with your developers so that they can start taking actions on the open source components that are being used in their organization. Okay. Now, one quick enhancement or recommendation that I have from my side, and I see that this is a very good way to improve the security and monitoring by integrating your SCA tool with a binary repository manager. A quick background on what a binary repository manager is. All the packages, dependencies, as well as libraries that you are consuming, they need to be stored in a binary repository manager rather than in a NFS file store or a SharePoint drive or in some kind of a Git VCS system. This is something that I have seen in the field that DevOps practitioners are having a challenge with, because having the binaries or executables or artifacts that your organization is producing stored in a NFS file share or SharePoint or some kind of a storage solution will not going to serve you well, because you need these repositories to be maintained. The repository indexes specific to Docker, NPM, Maven, Go, PyPy, these indexes should be maintained automatically. And at the same time, it should be much more easier to maintain and manage the metadata around the binaries consumption. So in this case, in our dev environment, having a binary repository manager, create a remote repository which can proxy cache these public registries, can also give you more visibility and traceability around what set of dependencies each of your teams or developers are consuming. And at the same time, you can start enforcing a default global policy that your organization can have. For example, any vulnerability that is of high or critical level severity cannot be consumed by developers as a dependency. So you can start enforcement in the stage one itself, in the first phase of the DevOps implementation itself, by enforcing these kind of a binary repository manager and having continuous and automated security scans being performed by an SCA tool integrated with your binary repository manager. In case of JFrog, we have a Artifactory as our binary repository manager, and X-Ray, which is our software composition analysis tool, can natively integrate with Artifactory and can make these scans automated and have these automated actions triggered as a one-click DevSecOps automated actions inside the policies that you can create in X-Ray. So basically, this is how the remote repositories can help. And by scanning the remote cache that your developers are pulling, you can have one more level of standardization and enforcement get into the place. And also now you have a clear-cut list of public registries that your developers are relying on. And at the same time, you can also make sure that you get the visibility on what set of libraries or dependencies that they're pulling in from the internet. Keep in mind that it involves a change in the implementation, because previously we have seen the developers directly consuming these dependencies from public registries. Now you have to enforce some kind of a networking rule or firewall restriction, stopping them from consuming the dependencies directly from the internet, and request everything from Artifactory. And in this case, based on the list of sources that you have that your developers are relying on, you can finalize the list and create remote repositories inside a binary repository manager that can perform the on-demand proxy caching of these public registries. So basically, anything that is demanded or requested by your developer will be cached inside the binary repository manager. So this is a good way to implement the enforcement in the dev stage itself. Any questions here? Okay, let's go ahead and move to the next slide. Let me do a quick time check. Steve, can you remind me how much time do we have?
Got about 20 minutes left.
Okay, thank you. Now, so I have talked about enforcement and creating policies. Just to get you acquainted, again, this is slightly a security topic, but nowadays the security practices are being part of the entire DevOps implementation, and organizations are moving from DevOps to DevSecOps and making sure that the security is part of the DevOps workflows. And this is where I think as a part of the DevOps community, we should be also aware of these security policies and licensing policies and some of the security jargon that I'm going to talk about. So as a quick background, these NVD databases and other publicly available vulnerability database sources use a standard using which they measure the criticality level of a given vulnerability that is detected in a package. The first one is the CVSS score. The latest standard is CVSS v3, and usually the score lies between 1 to 10, 10 being the most critical and 1 being the least critical. You can also go with the severity level, and these are the 4 levels that are available: critical, high, medium, low, and there's an unknown severity level as well for newly detected vulnerabilities. And this is the common standard to determine the impact on your organization. Also here, a quick note, some SCA tools can also give you application contextual analysis. For example, a critical level severity might be found in your Docker image, but you might not be actually being impacted by the given vulnerable library because of various reasons. Maybe the port on which the application is running is being blocked as a part of the Docker configuration. Sometimes the vulnerable function might not be invoked by using some safe flags under the context where the library is being utilized. So these are some of the ways in which you might not be impacted even if there's a critical level severity being ingested as a part of your application. So those are some of the advanced capabilities that are available when it comes to enforcing security policies. So keep in mind, like do evaluate these tools, these SCA tools who can provide these sort of contextual analysis as well, because this is going to really help you in gathering the information and taking the action on the right set of alerts in the first place. Okay. And these security policies can be global and can be a common policy across all the teams and repositories and builds in your organization, or it can be a team specific policy as well. So like evaluate these set of criteria points as well when it comes to an SCA tool to define global as well as team specific policies. Again, as a security practitioner, I would recommend you to have both types of policies enforced in your organization. Same way, there can be a licensing policy as well. You can have a list of allowed licenses prescribed by your legal teams, or list of disallowed licenses prescribed by your legal compliance teams, and you can apply it at a global level as well as team specific as well. So I see that a lot of emphasis on the type of policies being different in different set of organizations. Mostly banks and federal organizations are mainly concerned about licensing policies because most of the time either the infrastructure or environment is completely air-gapped, and they're mostly worried about licensing or compliance aspect of it. In mainly the public-facing websites or applications or software organizations that are developing software that is public-facing, I see more emphasis on the security as well as compliance sides. Okay, just as a pattern, what I've been observing. So this is how you create the policies and define the minimum required criteria for a given open source component can be utilized in an organization or not. Again, with the Log4j vulnerability being a big exercise, having these policies enforced in an automated fashion in your SDLC lifecycle chain, like changes or phases, will be greatly helpful, because security can be a integral part of your DevOps implementation by using these automated security and licensing policies. Okay, have you come across these sort of policies, or any questions on how you can define these policies as such? I'm just curious if anyone has went through this exercise in your organization, or if you have any questions or feedback here. Okay, let's go ahead to the next slide. Now, the second approach can be monitoring the dependencies that your CI tool is consuming. Again, here it is much more easier, because generally speaking, these DevOps tools or CI tools are handled by the central enterprise level teams. This can be DevOps teams or separate build teams that are maintaining these tools, or developer enablement teams that maintain these tools. And in this case, you can see that they're usually integrated with a version control system or a Git system. Whenever there's a nightly or commit based triggers, they kind of pull the latest version control changes and build it locally in the CI tool, and at the same time resolve the dependencies from the remote public registries. Here, by having an SCI tool employed as a part of your build or CI build stage, can help you get aware of what the vulnerabilities or licensing issues associated with the given build. And at the same time, these SCI tools can also produce an SBOM for each build that you can that you can submit for auditing or compliance purposes for the downstream automation purposes, right? So that's where monitoring the builds can be helpful. And of course, if a vulnerability is detected at this stage, it is quite tougher than the dev environment, because it involves a bunch of changes made to the source code, and the feedback has to be relayed back to the developer to implement any changes. So there's a lot of feedback cycles involved, and a lot of organization resources in terms of time and man hours that will be spent in order to address the given issue if it is found in the CI environment, right? Any questions here? So one quick recommendation or approach that I see is beneficial for DevOps teams is that if they integrate a binary repository manager with the CI tool and have a dedicated registry serving both the dependencies that the organization is relying on or the CI tool is relying on, and at the same time capture the build that is coming out of the build process and store these artifacts in a binary repository manager, it's going to greatly help you. In terms of performance and reliability, because these dependencies are cached from the public registries for the first time when they are requested by the CI tool, the next time the dependencies are pulled by different CI pipeline or the next version of the build being built by the CI tool, this time around, because these dependencies are readily available in the cache, they readily serve the CI tool. So your builds are much more faster and more reliable as well. Even if in case your public registry that you're relying on, it is serving not only just your organization, but millions of other users and developers. So it might be slow, it might be unavailable, or the specific dependency that you're relying on has been removed by the author. So you won't be impacted by all of these changes. And at the same time, you have full traceability here in case if it is integrated with a binary repository manager. And you can also follow something called curation and carefully pick and select what set of dependencies can be available for the approved CI tools or build environments. In that way, this is a whitelisted repo serving the CI tool and an open DMZ repo that is open for all the developers to pull anything that they need from the internet. So this is also one of the approach that I've seen with DevOps practitioners, wherein anything and everything is open to the developer to consume. But when it comes to the CI tool, they maintain a whitelisted set of artifacts or dependencies that the CI tool can consume. So in that way, they're enforcing that only whitelisted or approved libraries can be utilized inside the organization's pipeline. Okay, so this is one another approach that I've seen is greatly serving the organizations and is being beneficial to the users. Any questions on this approach or feedback around this implementation? Okay.
I do love the whiteboard annotations. 10 points.
Thank you. And one more thing, if an SCA tool that you have supports this policy engines, you can have a dedicated policy for your dev, which can be more lenient and open, whereas a dedicated policy for your CI/CD environment, which is more stringent and can have good set of standards defined for your organization. So this policy enforcement is automatic in nature and should be continuous in nature. When it comes to the JFrog platform, we perform continuous analysis, so you don't need to worry about it and rely on X-ray as your DevSecOps gatekeeper, and just modify the policies as you see fit for your organization. Okay, so that is something that you need to take care of when selecting an SCA tool, and the approach that you're going with on what policy suits for your developers and what policy suits for your CI environments. Okay. So couple of other important things that you need to be remembering. In the CI server or the build stage, there's a enhanced capability that you can perform. Always, not all the dependencies that are being part of the build process is part of the actual package coming out of it. So you can tag dependencies to the software bill of materials manually as well in the CI build phase. That will further enhance the SBOM. Basically, not only just the binary, but the SBOM can also be used as a means to list out the open source components that are part of your given software application. So in case the given dependency is acting like a catalyst or being obfuscated from being detected by an SCI tool, maybe the given dependency is part of an encrypted layer. So you can enhance the SBOM to get the scan results done as well. So again, maintaining the full system of record is greatly beneficial because this obfuscated dependency might have some vulnerability or compliance issue associated with it, and you need to make sure that it is part of the scan result. Okay, let me just move to the next approach. So this is something that a lot of organizations might be missing. A security scan or an SCS scan cannot be a snapshotted scan. Today, you might certify the given artifact to be approved and utilized in the organization. For example, all the Log4j instances that the software organizations have been utilizing since the last 10 years, at some point or the other, they might have scanned it. And at that point of time, the given Log4j library was qualified to be utilized in the organization. Now, there are new set of exploit techniques or vulnerabilities that are being detected in a day-to-day basis, and these central vulnerability intelligence platforms are being updated in a daily basis about these vulnerability updates. Now, that's when you see that the Log4j that is already in the production has some issues. So that's why the scans cannot be a snapshotted events in the dev phase or build phase, I see that these scans should be continuous in nature and should be enforced in every stage of the DevOps workflows, in test, release, deploy, and operate as well. Okay, so that's where I see that one of the popular approach that DevOps practitioners are taking up. Again, this is a long-term goal that they are looking towards, is implementing the OSS scans in every SDLC stage. And in this sample diagram, I have just dev, QA, release, UAT, and prod, like 5 stages. In some organizations, this can be 3, this can be 10 stages, but you need to make sure that there's an SCS scan at every stage to make sure that your software is secure all across these stages. And even if the given software application is shipped into the production, you should still employ an SCA tool to know what are the open source components that are running in your production and get alerted about these when a given new set of vulnerability is detected, and the relevant automated actions should be taken up. Of course, as you move towards the right, the number of artifacts or builds will decrease. For example, there might be hundreds or thousands of snapshot builds that are being delivered or coming out of your organization in a given day, but only few of them will pass all the tests and get qualified, and ultimately may get deployed into production. Maybe 2 of the 1,000 will get deployed into the production. So as you move towards the right, the number of artifacts will decrease, but the criticality level of the artifact will increase. And you always need to prioritize the alerts that are being found in the prod in the first place, and then slowly move towards the left. But as I mentioned, shifting left as much as possible and implementing these automated scans very early on in the DevOps implementation will help you in terms of lesser time to remediate and lesser CapEx and OpEx or the total cost of remediation that you're going to employ. So again, this is a mix of all the things that we have talked about, but what I am mentioning here is that it is very important to monitor the OSS reliance and compliance and security at every stage of the SDLC. And very few organizations have the bandwidth and resources to do this. And an SCA tool with a comprehensive global level as well as project level policies can greatly help you simplify this problem. Okay. Any questions here? So you might be wondering how you can get a knowledge of what is running in your prod, what is running in your UAT and release, or QA and dev environments. So as a best practice, you always need to segregate the binaries or artifacts that are being utilized in the organization in separate repositories, rather than having one single monolithic repo for all the SDLC lifecycle stages. So this will ensure that you have designated locations where you can pick up the relevant candidates that needs to be tested or deployed for the given stage. For example, QA repo for the QA test engineers. Ops teams will rely on release and UAT repositories, and production automated deployment tools will rely on the prod repo, for example. So this is also something that you need to carefully implement in your organization. Of course, this takes a lot of time and effort, and this is something I see as a good roadmap for organizations working with binaries and trying to implement DevOps in their organization. So I tried to make some time for the demo, but I see that we are on top of the hour, so I will not be able to do a demo, but let's conclude on what we have learned today. So we have learned about various approaches and various stages at which you can implement an SCA tool or a software composition analysis tool to get to know what sort of OSS components or open source components that you're relying on, and evaluate the security and licensing status of your organization by mapping this list of software components that are found with the central vulnerability and intelligence platforms, and also triggering various various automated actions. We have talked about how an SBOM can be generated by an SCA tool and can be exported, and also integrating an SCA tool with a binary repository manager can enhance the SBOM and collect various other additional data points as well. And we have looked into some of the approaches that various organizations are taking to address this challenge of maintaining and monitoring and managing the open source software consumption, and what are the best practices around it. And we have also looked at why it is important to maintain these scans all across the DevOps lifecycle stages, and mainly as the binary is the entity that is traveling all across these DevOps SDLC lifecycle stages, you need to take a close tap on scanning these binaries and making sure that these scan results are continuous in nature, so that you can stay on top of these alerts and address these issues as they come out of the SCA tool. Thank you for joining me today, and hope this presentation is helpful and giving you a thought on how you can address these security issues coming out of open source components.
Thanks so much, Gowtham. That was great.
Thank you, Steve.